Something extraordinary happened on July 1st, 2025, when astronomers at the Atlas Survey Telescope in Chile spotted an object moving through our solar system unlike anything they'd seen in years. They designated it 3I Atlas, the third confirmed interstellar visitor, and within weeks, it became clear this wasn't going to be another routine discovery. This visitor from beyond our solar system was about to challenge everything we thought we knew about comets and force us to ask questions that most scientists prefer to leave unspoken. Welcome back to Beyond the Stars. Let's discuss. What makes 3I Atlas so profoundly unsettling isn't just one anomaly. It's the accumulation of impossibilities that, when viewed together, creates an average power that refuses to conform to natural explanations. The object arrived on a trajectory aligned within 5 degrees of our solar system's ecliptic plane, the flat disk where planets orbit. The probability of this alignment happening by chance, 0.2%. It's like throwing a dart from across a football field and hitting the bullseye without looking. Then came the observations that made veteran astronomers pause their coffee midway to their lips. During July and August, as 3I Atlas approached the Sun, it displayed something called a sunward jet, an antitail pointing directly toward the Sun rather than away from it. Natural comets don't do this. The geometric perspective that creates similar illusions in regular comets doesn't apply here. This was real material being ejected in the wrong direction, powered by forces that shouldn't exist in a chunk of ice and rock. But size became the real problem. Hubble Space Telescope observations revealed a nucleus no larger than 5.6 kilometers in diameter, possibly as small as 440 meters. Yet this relatively tiny object was generating a gas plume that required it to be 1,000,000 times more massive than Oumuamua, the first interstellar visitor, and 1,000 times more massive than Borisov, the second. The mathematics simply didn't work. It was like watching a campfire produce the energy output of a forest fire. Harvard astrophysicist Avi Loeb, a man with over 1,000 peer-reviewed papers and decades of astronomical research, started running calculations that led him places most scientists feared to go. He discovered that 3I Atlas contained far more nickel than iron, a composition seen in industrially produced nickel alloys, not natural cosmic bodies. The ratio of nickel to cyanide was orders of magnitude higher than any known comet. Natural processes don't create these proportions. Manufacturing does. As 3I Atlas swept past Mars in early October, NASA's Mars Reconnaissance Orbiter captured what should have been the clearest image of the object. The HiRISE camera on October 2nd had a perfect view from just 30 million kilometers away, but that image wasn't released. Not during October. Not during the perihelion passage on October 29th, when the object came closest to the Sun. The federal government shutdown was blamed for the delay, but the timing felt agonizingly deliberate to observers waiting for answers. What happened at perihelion on October 29th, 2025, at exactly 7:47 a.m. Eastern Time, became the subject of intense speculation. If 3I Atlas was a natural comet, held together by weak icy bonds, the 33 gigawatts of solar radiation hitting its surface should have torn it apart. The heat should have created a spectacular fireworks display of fragments and gas. Natural bodies break under that kind of stress. They always have. But 3I Atlas was hidden behind the Sun during this critical moment, invisible to Earth-based telescopes, leaving us blind at the exact moment when we needed to see most. Post-perihelion data released in early November revealed something that deepened the mystery rather than solving it. The object had brightened by a factor of 5 in certain wavelengths. More concerning, it exhibited what JPL and the Minor Planet Center carefully termed non-gravitational acceleration. The object was moving in ways gravity alone couldn't explain, deviating from its predicted path by margins measured at 3.7 standard deviations, a statistically robust detection. Something was pushing it. The question was what? Loeb proposed 2 possibilities, and both were uncomfortable. Either 3I Atlas had fragmented at perihelion, creating multiple pieces that were still traveling together in a cloud too dispersed to resolve as separate objects from Earth's distance. Or the acceleration came from something else entirely. Technological propulsion, an engine, the kind of system that could produce thrust without the massive material loss that natural outgassing requires. The characteristics supporting the technology hypothesis kept mounting. 3. iAtlas showed no non-gravitational acceleration based on analysis of 4,022 data points from 227 observatories worldwide. The object was coasting, following a purely gravitational path. Then, suddenly, after perihelion, acceleration appeared. Natural comets don't turn their engines on and off. Natural comets don't wait for optimal moments to change their trajectories. But a spacecraft performing what's called an Oberth maneuver, using the sun's gravity to amplify thrust at perihelion, that would look exactly like what we observed. The timing of 3 iAtlas arrival presented another puzzle that seemed too precise to be coincidental. The common face of fire properly argues that there was also essential for results. Its trajectory was fine-tuned to bring it within tens of millions of kilometers of Mars, Venus, and Jupiter, while remaining unobservable from Earth during perihelion. The probability of this timing occurring naturally? 0.005%. It's the astronomical equivalent of someone walking into your house, making themselves a sandwich, and leaving without being seen, all while you're in the next room. NASA's official position remained cautious but firm. Multiple space assets tracked the object, including Hubble, Webb, the Mars Reconnaissance Orbiter, Europa Clipper, the Lucy spacecraft, and numerous others. The next chapter begins in less than a month. The data will arrive. The images will be processed. The truth, whatever it is, will be there in the pixels and spectra and orbital solutions. Whether that truth confirms our assumptions or shatters them depends on what 3 iAtlas reveals when we look at it with our most powerful instruments during its closest approach. Until then, we wait, we wonder. And somewhere in the darkness between stars, 3 iAtlas continues its journey, carrying secrets we may or may not be ready to receive. The answer arrives December 19th, when Webb turns its instruments on 3 iAtlas. Subscribe so you don't miss what could be the most significant astronomical discovery of our time. Drop your prediction in the comments. Are we looking at a comet or something that will rewrite the textbooks? See you in the next one.